my dear students, welcome to the next session class on Fourier series. In last class, we have seen about what is Fourier series and Euler's formulae. In today's class, we'll see the problem how we are going to implement the Euler's formulae for finding the Fourier series for the given function. Even I have said you the basic formulas which we are going to utilized in Fourier series. So let's start with the problem. First problem, express f of x is equals to x minus pi as Fourier series in the interval minus pi to pi. What they have given here, the problem, they are asking you to write the Fourier series for the given function where your function is f of x is equals to x minus pi is your function. So now here you have to find a0, an and bn values. The solution. First we will write the formula, Fourier series formula. f of x is equals to a0 by 2 plus summation n is equals to 1 to infinity an into cos nx plus bn sin nx. This is the formula, and we will give this Fourier series as equation number 1. We have to find a0 value, an and bn value, where this summation for both the terms an and bn. Given f of x is equals to x minus pi. Next, to find a0. What's the formula for a0? a0 is equals to 1 by pi integrating minus pi to pi f of x into dx. Now substitute your function. a0 is equals to 1 by pi integrating minus pi to pi x minus pi into dx. It's equals to 1 by pi integrating minus pi to pi x into dx minus 1 by pi integrating minus pi to pi into dx. What I did, I have multiplied this integrating to both the terms in the bracket, where f of x, where f of x is odd function. When it's odd function, limits from minus a to a. Here what is the a value here? It's minus pi to pi. So directly we can write this integrand is going to be 0. Since we know that integrating from minus a to a, f of x into dx is equals to 0 when it's equals to 0 when f of x is odd function, where f of x is odd function. So this integrand is completely going to be 0 minus 1 by pi of, and where pi is a constant, so I will take that pi is also out of the integration from minus pi to pi 1 into dx, where this pi and this pi will get cancelled. It's equals to minus of x, limits from minus pi to pi. Integration of constant its respect to whatever it's going to be. So we are doing the integration with respect to x. So it's coming as x. It's equals to minus of upper limit minus of n minus lower limit. It's equals to minus pi plus pi. It's equals to minus 2 pi, where a naught value is equals to minus 2 pi. Now next we have to find your an. To find an, where an is equals to 1 by pi integrating minus pi to pi f of x into cos nx into dx. Now substitute your function. In the last class, what I have said you have to utilize your Bernoulli's integration by parts, and every time you are going to consider the function under u and trigonometric function under v. Therefore we know that u into v dx is equals to u v1 minus u dash v2 plus u double dash v3 plus so on, where your u dash stands for differentiation and v stands for integration. So what we will do, we will consider this part under u we will take, and this part we will take under v, so that the problem should wind up as early as possible. If you are going to take it in opposite, then there is no end to the problem, because your cos is going to be going on differentiating, and x is going to be going on integrating. So every time you are going to consider your function under u and trigonometric part under v. So your u, it's equals to x minus pi, u dash is equals to integration of x is what? Integration of x, integration of your x is 1 minus a constant, it's a 0, u double dash, it's equals to 0. Next your v is equals to cos nx, where v1 integration of cos, it's sin nx by n, and where your sin integration is equals to minus cos nx by n. Got it? Next, substitute into the formula. An is equals to 1 by pi of u is equals to x minus pi, and v1 it's equals to sin nx by n minus u dash value is equals to 1, and v2 is equals to minus cos nx by n, and next term your u double dash value is equals to 0. So next so on it's going to be 0, limits from minus pi to pi, and since we know that since sin n pi value is equals to 0 and cos n pi value is equals to minus 1 to the power of n, so the first term is going to be vanish. An is equals to 1 by pi of 0 minus into minus plus cos nx by n, limits from minus pi to pi, and this n I will take out of the integration, n pi of cos n pi minus cos n of minus pi, and where we know the trigonometric identities. We know trigonometric identities. Sine of minus x is equals to minus sine x. Cos of minus x is equals to cos x. So this how we can write? An is equals to 1 by n pi of cos n pi minus cos n pi, where n pi and n pi will get cancelled. We are going to left with an is equals to 1 by n pi of 0. So an is equals to 0. So we got one more value also. An is equals to 0. Next we will find bn. To find bn, where bn formula is equals to 1 by pi integrating minus pi to pi f of x into sine n x into dx. bn is equals to 1 by pi integrating minus pi to pi f of x is equals to x minus pi into sine nx into dx. Again take this part under u and this part into v, where your formula is what? uv1 minus uv dash, u dash v2, then plus u double dash v3 minus u triple dash v4 plus so on. It's equals to 1 by where your u is equals to x minus pi and your u dash is equals to 1, u double dash is equals to 0. V is equals to sine nx, v2 is equals to minus cos nx by n, v3 is equals to v1, this is v1, this is v2. v2 is equals to minus sine nx by n square. Now substitute into the formula. bn is equals to 1 by pi of u is equals to x minus pi, v1 is equals to minus cos nx by n, then minus u dash value is equals to 1, v2 is equals to minus sine nx by n square, then u double dash value is equals to 0. So the remaining values are going to be 0. Limits from minus pi to pi, where sine nx n pi, sine n pi value is equals to 0, cos n pi value is equals to minus 1 to the power of n, and trigonometric sine of minus x is equals to minus sine x, cos of minus x is equals to cos x. Now utilize that one. bn is equals to minus, this minus complete I will take out, minus even n also will take out, n pi of x minus pi into cos nx, limits from minus pi to pi. Now substitute your upper limit minus lower limits is equals to minus 1 by n pi of pi minus pi into cos nx minus of minus pi into cos of minus pi. The first term 0, it's equals to minus 1 by n pi of 0 minus into minus 2 pi, and cos of minus pi we can write cos pi by using the identity minus into minus plus, minus 2 pi divided by n pi minus 1 to the power of n, where this pi and this pi will get cancelled. we are left with Bn is equals to minus 2 by n minus 1 to the power of n. Where this minus, how we can represent minus 1, we can write 1 into something, it's going to be something. So this minus I have written as minus 1, 2 by n minus 1 to the power of n. Bn is equals to 2 by n minus 1 to the power of n plus 1, where Bn value is equals to what? 2 by n of minus 1 to the power of n plus 1. Now what we will do? Substituting a naught, an and bn values in equation number 1, where we have written the formula. F of x is equals to a naught is equals to minus 2 by 2 pi by 2 plus summation n is equals to 1 to infinity, an value was 0 into cos nx, then bn is equals to 2 by n minus 1 to the power of n plus 1 into sin nx, where f of x is equals to x minus pi is equals to this 2 and this 2 will get cancelled. It's minus pi plus summation n is equals to 1 to infinity 2 by n minus 1 to the power of n plus 1 into sin nx. This is the required solution. Still you can simplify if you want. This 2 you can take out of. You liked my way of explanation and you got all the steps clearly, then only like my video and share among your friends who need a help to get this topic clearly. If you are new on page, please subscribe to my channel. Thank you for listening me. We will meet in next session class with some other problem.